Hi everyone. In this video, I'm going to work on solving an equation that requires me to use the double angle formula. Okay, so this is solve. Really pay attention to those directions. There's some verify identities and there's some solve equations, and that's very different. So I am actually trying to get down to the x values that make this statement true. And right now I have two problems looking at this equation, two things that are making it challenging. One is that there are two different trig functions, sine and cosine, and that in general can make life a little hard. You can try and do some division to turn it into tangent as one option, but even that won't save me here because I also have different angles. So if I divided everything by cosine x, I still wouldn't be able to turn this into a tangent because the angles are different. So I'm going to tackle the angle problem first because I absolutely know how to do that. I know that sine of 2x is the same as 2 sine x cosine x. So I didn't get rid of the fact that I have two different trig functions, but I absolutely dealt with the two different angles part. So that's no longer an issue. So I think the trickiest thing here is just spotting that. People get really stuck on this and they just don't even think to use the double angle formula. So yes, when you're doing your homework, you know you should be looking for a double angle formula, but definitely before you get tested on this, it would be a great idea to mix up problems from all the different sections and see if you still spot when you're just doing your usual solving, when you're needing a sum formula, when you're needing a double angle formula. To continue with this problem, I can get out of my trouble with the two trig functions by factoring. I can factor out a cosine x, and that leaves me with a 2 sine x plus 1. And this works out beautifully because I can now set each factor equal to 0. And when I do that, I no longer have a mix of two trig functions in any one equation. So I'm interested in when cosine x equals 0 and when sine x equals -1/2. And if I go to my unit circle, I would say cosine x equals 0 right at the top or the bottom. So that's pi over 2 and 3 pi over 2 are one of the possible arc lengths for each of those points. And then sine x equals -1/2. That's going to put us at 7 pi over 6 and 11 pi over 6 or negative pi over 6. Okay, so those are the points that I'm interested in. Because this doesn't specify, the safe assumption would be that we should give all solutions. So I do write the all solutions sometimes, even though that should be implied. But definitely, if you don't see directions to only give specific solutions, you should give all of them. So I do get one equally spaced pair, but that's about as good as I can do for making this statement brief. So I'm just going to say that x could be pi over 2 plus pi k, and that will get that top and bottom point. Or it could be 7 pi over 6 plus 2 pi k. That one doesn't line up, isn't equally spaced with any of the other points, so we'll just go all the way around the circle to get back to that point over and over and over again. Or x is equal to 11 pi over 6 plus 2 pi k. Once again, there's no equal spacing with that point and any other point, so we'll just go all the way around the circle and stop at that exact same point over and over and over again. Okay, and that's our solution for that problem. For number 6, we have kind of a similar situation. I have two different trig functions, sine and cosine, which is going to make things a little tricky. If I can, I'd like to fix that. Although you saw in the last one, sometimes there are ways around it. I also have the two different angles, alpha and 2 alpha. I definitely know how to fix that. So I'm going to start with that one. So again, just really make sure you watch for those 2 alphas. If they're both a 2 alpha, probably not a huge deal, but if one is a 2 alpha and one is an alpha, that's when you're going to want to try and switch things around. Okay, so sine of alpha is fine. If we look back at our formulas for cosine, it's this trio right here. We can turn cosine of 2 alpha into a combination of cosine squared sine squared, into only sine squareds, or into only cosine squareds. And since my other function is a sine function, I'm going to choose this one. Then I won't have any cosines left. So I'm going to replace the cosine of 2 alpha with a 1 minus 2 sine squared alpha. Okay, so I end up with this, and I can see a couple of things. One is that the ones are going to go away, so we can go ahead and just subtract 1 from each side and get rid of them. And then it's not really going to end up mattering, but I don't love the negative sine squared, so I'm just going to go ahead and move everything over. I'm going to say I have 2 sine squared alpha minus 1/3 sine alpha. And then at this point, we could just factor. We have a common factor of sine, so we're going to factor that out. I'm going to go one more step and clear the fraction. If you don't feel like you need to do that, that's fine. It's not a required step, but it's a pretty quick way to not have to look at fractions when you're solving. Okay, so here I am. I factor out a sine of alpha. I'm left with a 6 sine alpha minus 1. And now I can split it up and say, okay, then either sine alpha is equal to 0 or 6 sine alpha minus 1 is equal to 0. The second is only true if sine alpha is equal to 1/6. So on my unit circle, I'm going to say sine equals 0 if I'm at the left or right hand side of the circle, and sine equals 1/6 just above those 2 points. So this is what my solution set looks like. So once again, I have an equally spaced pair, the points 0, pi, 2 pi, so on. So for that one, I can just say alpha is equal to pi k. It's like a 0 plus pi k. And that's all we need to describe the far left and right hand sides of the circle. To describe the top 2 points, I first need to do an inverse sign. It's getting a little scrunched. So one value of alpha is going to be approximately inverse sine of 1/6, which is about 0.17. Okay, so alpha is about 0.17 plus 2 pi k. So that was this point right here. That point sits at the end of an arc length of 0.17. There's no other point that has equal spacing with that one. So we'll have to go 2 pi around the circle to just hit that point over and over and over. And then the last one, we'll have to use a little symmetry. The calculator won't give us this arc length, but hopefully we can see that if this is 0.167, so is this. So we need a pi minus 0.167. And then again, we will stop every time we go around the circle so that we catch all the arc lengths that land at this point. All right, thanks for watching.